NASA wants a new mission to Uranus, and honestly, that should freak you out a little, because this is the planet with 42-year nights, poison clouds, sideways seasons, and a past so violent it may have knocked an entire world over and left the scars behind forever. The more we study Uranus, the more it looks deeply, fundamentally wrong. Let's get into it. Chapter 1. The news makes Uranus feel worse, not better. Uranus is having a weird comeback. In late 2024, NASA's Hubble Space Telescope and New Horizons looked at the planet from two very different viewpoints at nearly the same time. Then, in April 2025, a NASA-led occultation campaign used observatories across Earth to study the temperature, density, and pressure of Uranus's upper atmosphere in detail, partly to help prepare for a future mission that could drop a probe into that atmosphere. And hanging over all of this is one huge fact. The National Academy's latest planetary decadal survey made Uranus Orbiter and Probe the highest priority new flagship mission, and NASA has said pre-formulation studies are beginning in the current budget horizon. So yeah, Uranus is suddenly not just that distant joke planet anymore. It's one of the most important worlds in the solar system to understand next, and honestly, that makes the planet scarier, because the closer science gets, the less Uranus looks like a calm blue ball drifting in peace. The new attention is not revealing some gentle outer planet paradise. It is revealing a world of broken geometry, brutal cold, toxic chemistry, and a day-night cycle so extreme it almost feels fictional. You look at Saturn and you get grandeur. You look at Jupiter and you get force. You look at Uranus and you get this creeping feeling that something terrible happened there a very long time ago and the planet never recovered. That is what makes Uranus such a perfect horror planet. It does not scream at you. It doesn't show off. It just sits there in pale blue silence, almost featureless at first glance, like it has nothing to say. But the second you start asking basic questions, why is it tipped over? Why is it so cold? Why is the magnetic field so messed up? Why does one side live in darkness for decades? The whole thing starts turning into a cosmic crime scene, and once you see that, you cannot unsee it. Chapter 2, Uranus looks calm, but the planet is deeply wrong. To the naked eye, Uranus almost looks boring. That is part of the trap. It is not wrapped in Saturn's bright rings, and it does not have Jupiter's huge striped atmosphere screaming, "Look at me." Uranus looks smooth, pale, quiet, distant. Voyager 2's 1986 flyby did not help that image much either. The first close views made it seem like a blank billiard ball, a planet with almost no visible drama at all. But that first impression turned out to be wildly misleading. When scientists look with better instruments, different wavelengths, and more context, Uranus starts looking less like a sleepy ice giant and more like a place where normal rules got bent hard. Because almost everything about Uranus feels off, it does not spin in the same basic upright way the major planets mostly do. Its magnetic field does not behave like the neat centered magnet you would expect. Its seasons are not just intense, they are ridiculous. Its atmosphere is the coldest among the planets. Even its rings and moons feel dark, battered, and a little cursed. This is not one weird feature. This is a stack of weird features, all sitting on top of each other, all pointing back to one central idea. Uranus is not just different, Uranus looks damaged. And here is where the horror really starts. A planet can be harsh and still make sense. Jupiter makes sense. Neptune makes sense. Even Venus, as awful as it is, makes a kind of brutal scientific sense. Uranus is different. Uranus gives you the feeling of walking into a room and instantly knowing a fight happened there, even if nobody saw it. The furniture is wrong, the walls are wrong, the silence is wrong. That is Uranus, a whole planet where the silence feels suspicious. Chapter 3, something knocked an entire planet over. The biggest clue is the tilt. Uranus is tilted by about 98 degrees. That is not a slight lean like Earth. That is not even a dramatic lean. That is a planet basically rolling around the sun on its side. If you zoom out and picture the solar system from above, most planets spin like tops. Uranus does not. Uranus looks like it got shoved so hard it never stood back up. Scientists think a giant impact early in the solar system's history is the most likely reason, maybe from an object roughly Earth-sized or bigger, smashing into the young planet and changing everything, and that one violent event may explain more than just the tilt. It may be the reason the planet's internal heat is so strangely weak compared with Neptune. It may be the reason Uranus feels like a colder, deader version of what an ice giant should be. Some ideas suggest the collision did not just knock Uranus over, it may also have helped vent or disrupt heat deep inside, leaving the planet unusually cold on the outside. That is not fully settled science, but it is one of those theories that fits the mood of Uranus way too well. Imagine a world hit so hard that even billions of years later, you are still seeing the thermal scar. That is what makes Uranus feel less like a normal planet and more like a fossilized act of violence. You're not just looking at a world. You are looking at consequences. The orbit, the seasons, the temperature, maybe even the strange inner structure, all of it may trace back to one ancient impact that changed the planet so completely it became the strangest major world in the solar system. A planet that does not just orbit the sun, but rolls through space like it is still recovering from being hit. Chapter 4. This is the planet of 42-year day and 42-year night. Now take that sideways planet and give it an 84 Earth-year trip around the sun. That is where Uranus stops being weird and starts becoming nightmare fuel. Because of the tilt, each pole can face the sun for an absurdly long stretch of time. That means one pole can sit in continuous daylight for about 42 years, while the other sinks into darkness for about 42 years. Not a long winter by Earth standards, not a rough season, a full generational wall of black sky. Try to actually picture that. Imagine being born into a place where sunrise is not coming next week, next month, or next year. It is just not part of your life. Your entire world would be stars, cold, and whatever dim light filters through a sky built from alien gases. Or flip it around. Imagine relentless light that never leaves. Not warm summer light like Earth, but distant, weak, emotionally draining light that just hangs there year after year over a freezing atmosphere. Uranus takes one of the most basic rhythms life on Earth depends on, the back and forth between day and night, and absolutely destroys it. And the creepiest part is that this is not just poetic. This extreme geometry shapes the atmosphere in ways scientists are still trying to understand. This is one reason Uranus matters so much scientifically. It is not just odd for the sake of being odd. It is a giant natural experiment in what happens when a whole world gets tipped into a completely different relationship with sunlight, seasons, heat flow, and space weather. That is why astronomers keep coming back to it. Uranus is not just an outer planet, it is a question mark the size of a world. Chapter 5. The beautiful blue atmosphere is a lie. Even the color is deceptive. Uranus has that soft blue-green tone because methane in the upper atmosphere absorbs red light and leaves the blue side of the spectrum more visible. So from far away, it looks serene. But that beautiful color is sitting on top of one of the harshest atmospheres in the solar system. The cloud tops can drop to around 49 Kelvin, roughly minus 224 degrees Celsius, making Uranus the coldest planetary atmosphere we know in the solar system, colder even than Neptune, which is farther from the sun. That alone would be enough to make the planet disturbing. But it gets worse. Uranus is mostly hydrogen and helium with methane and other trace compounds mixed in. Higher up, scientists have found evidence for hydrogen sulfide, the stuff that smells like rotten eggs. So if you could somehow survive the lack of oxygen, the brutal pressure differences, and the cold long enough to smell anything at all, the atmosphere would basically greet you with toxic freezer air and the stink of decay. This is why Uranus is so good at hiding its horror. It looks like a calm blue marble, but the closer you get, the more the illusion falls apart. There is no welcoming sky there, just chemistry that would kill you and temperatures that would turn exposure into a death sentence almost instantly. And beneath that atmosphere, there is no friendly, solid surface waiting for you. Uranus is an ice giant, but that label can fool people. This is not a frozen snowball you could stand on. Deep below the visible clouds is a vast high-pressure fluid interior made from substances like water, ammonia, and methane under extreme conditions. Some scientists even suspect that deep inside, carbon could be compressed into diamond rain, the same kind of exotic idea proposed for Neptune as well. Whether that exact picture is fully right or not, the basic point stands. The deeper you go, the less this planet resembles anything human beings are built to understand. with intuition. The planet becomes pressure, chemistry, and darkness. And then you get to the question that makes Uranus even more eerie. Where did its heat go? Most giant planets still leak a decent amount of internal heat left over from their formation and compression. Uranus barely seems to. It radiates surprisingly little extra energy compared with what it gets from the sun. That is one of the biggest unsolved mysteries around the planet, and it is such a perfect Uranus mystery because it adds to the same vibe. Again, something interrupted this world. Something left it colder, quieter, and stranger than it should have been. Chapter 6. Even the magnetic field feels broken. If Uranus had just one weird feature, you could shrug it off, but then the magnetic field shows up and makes the whole thing feel cursed. On Earth, the magnetic field is more or less aligned with the spin axis and generated from deep inside in a way that gives you a broad, recognizable, protective bubble. Uranus does not play that game. Its magnetic axis is tilted by almost 60 degrees relative to the rotation axis, and it is offset from the planet's center by about a third of the planet's radius. So instead of a neat centered shield, Uranus has this lopsided wandering magnetic mess. That matters because magnetic fields shape how a planet interacts with the solar wind, charged particles streaming outward from the sun. Uranus is already rolling through space sideways, and then on top of that, its magnetosphere is twisted and displaced. The result is a system that changes in bizarre ways over the course of a Uranian day, about 17 hours, and over the long Uranian year. Voyager 2 caught only a tiny snapshot of that behavior during its flyby, which means we still do not fully understand how that magnetic environment works, and if a future orbiter finally gets there, this is one of the huge reasons scientists want it. Uranus may be hiding one of the strangest planetary magnetic environments in the solar system. This is where Uranus starts feeling almost haunted by bad design. Sideways rotation, broken seasons, missing heat, and now a magnetic field that does not sit where it should. You can keep calling these fascinating anomalies, and scientifically that is true, but emotionally they stack into something darker. Uranus does not feel like a balanced world. It feels like a world that got scrambled. Chapter 7. The rings are dark, the moons are broken. Even Uranus's rings refuse to be pretty in the way people expect. Saturn's rings are bright, dramatic, almost theatrical. Uranus's rings are darker, narrower, and harder to love at first glance. They were only discovered in 1977 during a stellar occultation when scientists noticed starlight blinking out before and after Uranus itself crossed in front of a star. That alone is such a Uranus way to reveal rings, not with beauty, but with a subtle interruption in the dark. And then there are the moons. Uranus has 27 known moons, including Titania, Oberon, Ariel, Umbriel, and the deeply unsettling Miranda. Miranda is the one that really sticks in your head. It looks patched together like somebody shattered a moon, and then gravity stitched the pieces back into one ugly body. Giant canyons cut across it. Different terrains look like they do not belong together. And on Miranda sits Verona Rupes, a cliff about 20 kilometers high, the tallest known cliff in the solar system. On a normal world, falling from a cliff that size would be almost too fast to process. On Miranda, with its tiny gravity, the fall would stretch on and on. That is such a perfect Uranus image. Not even death would happen normally there. And the system is not done being weird. Some studies suggest inner Uranian moons may eventually collide over long time scales. So even out there, even in that cold, dim system circling a tipped-over planet, things are still unstable, still interacting, still drifting toward future impacts. Uranus is not a peaceful museum exhibit. It is a damaged system that may still have more wreckage ahead of it. Chapter 8. Why humans are not built for this planet. Now here is the part that turns Uranus from cosmic horror into personal horror. You cannot talk about this planet for long without asking the question, could we ever actually go there? Not just with robots, with people. And the answer, at least with any technology and biology we understand right now, is basically no in any reasonable sense. Uranus is around 2.9 billion kilometers from the sun, and even when it is relatively favorable from Earth, it is still unimaginably far away compared with somewhere like Mars. Voyager 2 needed a rare gravity assist chain and still took over 8 years to get there. A human mission loaded with life support, shielding, food, water, and everything needed to keep a crew alive would be far slower and heavier. Source text estimates putting a crewed trip at roughly 12 to 15 years one way are exactly why the whole idea turns dark fast, because the trip itself becomes the first killer, leave Earth's protective environment for that long, and cosmic radiation starts adding up in ugly ways. Not just cancer risk, but long-term damage to DNA, the cardiovascular system, the brain, and the immune system. Add years of weightlessness, and now bone loss, muscle loss, and changes to the heart stop being mission annoyances and start becoming identity-changing damage. The person who left Earth and the person arriving near Uranus would not be the same physically. That is before you even get to the psychological side. Decade-long confinement, delayed communication, no real sky, no quick return, no meaningful rescue. The isolation alone would be savage. And then you finally get there and Uranus still offers you nothing. No surface to stand on, no breathable air, no safe atmospheric layer where humans belong, just freezing cloud tops, violent winds that can reach around 900 kilometers per hour, crushing pressures deeper down, and a chemistry set that wants you dead. Even the magnetic field is too strange to imagine as some reliable Earth-style shield. So the final insult is that after a journey that could wreck your body, the destination itself is not a destination at all. It is just a pale blue warning that some parts of the solar system are for study, not for settlement. Chapter 9. This is exactly why we have to go back with robots. And yet this is where the story turns from horror into something almost irresistible, because the very things that make Uranus terrifying are the same things that make it scientifically impossible to ignore. We have only visited it once during a brief Voyager 2 flyby in January 1986, and most of what we still know up close came from about 6 hours of close science during that encounter. That is almost absurd when you think about how strange the planet is. One of the weirdest major worlds in the solar system, and humanity has only really looked at it once in passing nearly 40 years ago. That is why the current mission talk matters so much. A real Uranus orbiter and atmospheric probe could finally answer some of the biggest questions this planet keeps throwing at us. What does the interior actually look like? Why is the heat output so low? How does that bizarre magnetosphere behave over time? What are the true compositions of the atmosphere, rings, and moons? How did the planet get knocked over? And what did that do to the rest of the system? Recent observations from Hubble, New Horizons, and the 2025 Stellar Occultation Campaign are helping sharpen those questions right now, and they are doing it at exactly the moment when the science community is trying to turn Uranus from a forgotten flyby world into a priority destination. And there is another reason Uranus matters now. Ice giants aren't just local curiosities. Planets in this size range show up a lot around other stars. So understanding Uranus is not only about understanding one weird world in our own system, it is also about understanding a whole category of planets the galaxy seems to make pretty often. That is part of why the 2024 Hubble and New Horizons comparison mattered. Scientists were using Uranus as a kind of bridge between close-up solar system science and the harder problem of reading distant exoplanets from far away, which means every creepy mystery Uranus holds is also part of a bigger story about how planets work across the universe. Next time you see Uranus in a diagram of the solar system, don't think of it as the quiet one. Think of the darkness. Think of the decades-long night. Think of a planet rolling through the cold with a broken compass and a past written in impact scars. And if you enjoyed this video, subscribe for more insane stories from outer space.